Hello again, I'm Bill Wagner.
And I'm James Sturdivant.
And let's look at some examples of working through with delegates and events and how they're used effectively in the .NET framework. So let's look at the agenda for what we have in terms of our code review. We've got a few different sections we're going to look at.
Yeah, so first up, we're going to take a look at lazy of type T, and we're going to move on and take a look at task.trun. And finally, we're going to finish up by looking at system.progress, which is going to allow us to report the progress back up to calling code. And finally, we'll introduce the lab.
All right, so on the machine here, I've got lazy of T in place. So let's look at what lazy of T does. Lazy of T represents something that might be expensive to create, right? So somewhere in our code, maybe we have to go make a network call, maybe we have to do a tremendous amount of mathematical calculations to be able to get some result that we may or may not need in our application today. You know, like one of the apps I use on my phone a lot, I've got the ESPN app, and it automatically loads to the scores page. You know, another page has all the current news. Now, if I were to, swipe from one screen to another, that's when it's going to go load that other stuff. And another page is what people are talking about on sports on Twitter, which would be another request. So rather than when that app first loads, grabbing all that data, it might have something like lazy of T inside to say, well, I'm only going to get that data if you're going to look at it. So since it starts at the scores page, we automatically get that.
And so that really helps create the ability to load those pages quickly and get you into the app and get that user experience to be performant and ready for you to use. Right,
and be able to grab what we need lazily if I'm going to look at something else. So the key thing inside of lazy of T, so we've got that generic class again, is this idea of the M value factory, which is a field inside lazy of T. Notice that it's typed of func of T. So let's look at the definition of func of T. So func of T is a delegate, and it has one generic parameter, that T result, and it's going to return a type of T result. And notice that it has no arguments. So it's a function that returns T result. So if we go back into lazy of T, you can see that this is going to be a function that returns that result. It's going to calculate whatever it is and return it. And the way this gets used, one of the properties inside lazy of T is its value. So let's look at some of the parts that are inside here. And there's some of this part on the top has to do with boxing. So if the type that we're going to compute is a value type, there's some interesting little things that enable it not to necessarily get boxed because it's going to store it specifically in a certain structure.
So could you just give me a quick definition
of what boxing is? So we've talked a couple times in the way the .NET framework is defined that all types eventually inherit from system.object. Okay, system.object is a reference type, which means when I have a variable of type system.object, that variable is a reference. It refers to some location in memory that stores a system.object or something derived from it. There are types that are called value types. All the numerics are value types, int, byte, double, and so on. When we declare a type with a struct keyword instead of the class keyword, we create a value type. There, a variable doesn't point to some reference of some type. It points to the actual storage, or it has the actual storage inline of that object. So they're particularly used for small things that don't have polymorphic behavior, because value types we can't derive from. And they're typically used for storing, well, values. Now, the problem is if I write a very generic algorithm that's built on system.object at some point, in order to take a value type and cast it to a system.object, what happens is it ends up going into what's called a box, which is an object that contains the value, but gives us a reference so that it can act like a reference type, because system.object is a reference type. So boxing does a fair amount of work in terms of how it manipulates memory. And so what we're going to try to do is avoid too much boxing. And there's a lot of resources on the web. If you search for .NET and boxing and unboxing, you'll find a lot of really good articles by the part of the team that works on the garbage collector. And they'll have a lot of guidance and a lot more thorough and in-depth explanation of what I just described. So let's kind of go over this for a little bit. And here, the key part is when we look for the value of lazy of t, we're going to return from a method called lazy init value. And what that's going to do is it's going to, once again, deal with a little bit of boxing kind of stuff here. And then what we're going to say is, you know what, if I have never yet created the object that I'm getting from this lazy of t, let's go in and create that value. And create the value is now going to eventually go in here. We've got our factory, it's our mValue factory, and eventually we're just going to call, as long as it's not null and so on and so forth, we're going to eventually call that factory method right here. So we're invoking that delegate. And we're getting back the value that we're, depending on how it's stored and so on, we're going to put it in a box if we need to, and store that lazy of t value. Now there's two real interesting parts that come on here because of the way lazy of t works. Since we're calling this delegate later at a different point than it's defined, we have to deal with how should the exception semantic works. Okay, so let's say the method that creates my value throws an exception. The latter part of this method does some things where if we get some kind of an exception down in here, what we're going to do is we're going to keep track of the exception so that when you try to get the value later, because we've already called the method once, we'll throw the exception that was called the first time we tried to create it. So what lazy of t does is it says, I'm going to create this value when you ask for it. And whatever code you want to create the value, lazy of t is going to call that code. And then once it has the value, it'll return the value to you. Then, furthermore, what it says is, if when I do get around to trying to create the value, when lazy of t tries to create the value, if that throws an exception, when you try to get the value, well, I'll throw that exception again, because that's pretty much what would have happened if you weren't using lazy of t, but you just calculated it yourself. And then lazy of t has a few other properties, so we can look at things like is value created, so we can see if, without actually doing all the work, we can see if the value was created. So that's lazy of t. And if I were to use that, let's go into just a quick sample playground. And let's just say I were to define some class and say this is going to be some expensive property class. And somewhere inside here, I'm going to say I want to have a public, and we'll just say it's going to calculate a double for some expensive calculation. And I'm going to want to get that. And I need to somehow, I'm going to implement this get property to return some double. But in terms of using this, I may only call it once in a while, right? I may not always use it. So what I'm going to do to store that, instead of saying that I'm going to store some value, if it weren't so expensive, I might say I'm going to have a private double expensive value, and I might just say it equals math.py, okay? And then here I could just return that expensive value. Okay, that's our standard idiom for encapsulating this work. But if instead of just assigning to a constant, if this was a very, very expensive calculation, now let's say I'm going to make this a lazy of t, and in this case t is going to be that a double. And now, instead of being math.py, it's going to be a new lazy of double. And the way I'm going to initialize it is I want to call the constructor that is going to pass in that func. Okay, so for my purposes right here, I'm just going to say, here's my func, and I'm going to return math.py. Okay, just to show how this class is used. So now, if I were going to get pi, if I wanted to return expensive value, well, now I'm just going to return expensive value.value. I'm only going to assign this expensive value to the constant pi if it actually does some work. If some other code looks at it. More appropriately, this might be something to say, do some work to calculate. So it's going to be some other method that goes off and
so what we see here is we've actually are combining some of these concepts that we've been working with. We're using the generics to specify the type that lazy's returning, and then we're also using the delegates to pass in that function that's actually doing the work. You can see that Bill's building out this very complicated.
well, you know, it's not about some very
expensive calculation, and he's also using the lambda expression there to be able to pass that function into the solution there.
And this would now be a static method, and then we'll be okay. There we go.
There we go.
So now that's lazy of t. So we've got some stuff we can go compute this and do some things to decide, when do we want to do this calculation. And effectively what we're doing is we're just saying, when we want to do this calculation, here's the code you should run. Right? So the whole semantics of this being a lazy of t, the value isn't there until you actually ask for it and look for it. Once you look for it, then that value is there. That's all built into lazy of t. But lazy of t doesn't know how to do our expensive calculations. We have to write that code ourselves. And we can write some expensive math work here if we wanted to, but the idea is there that this is just simulating some work. So that's lazy of t. So what do we got next?
Next up, we've got task of t. And we kind of touched upon this in the last example here, but in the last module. But what we're doing here is we're specifying a function in some long-running task that we want to be maybe run on a different thread, but we don't want to have to manage all the threading ourselves. We just want to be notified when that comes back, and this is done through that asynchronous workflow that has been exposed in the latest version of the .NET framework. And so we're going to take a quick look at Bill's code here, and he's going to show us what task of t .run looks like.
Right. So one of the things we might do in a particular area is we might be running some task, and in this instance, so first of all, task of t is for asynchronous, which may be doing something on another thread, or it may be I/O bound. It may be a task to go make a network request, wait till we get the HTTP result back from some other resource. It may be file I/O, waiting for the file controller to come back, or it may be, as in the case of task.run, some work that's queued to run on another thread. So if we look at task.run, it has this parameter that's an action. And if we look at action, okay, that's simply a delegate that returns void. So this is just a function that takes no parameters and doesn't return anything, just does a bunch of work. The other one that we can look at there involved of task of t as well, there's a few overloads of it. And one of them should be right here, a task of run that has a func of t result. We saw that earlier. It's a method that doesn't take any parameters and returns some result. So this overload of task.run is going to start a task that returns a value. And the one that we looked at up here is going to start a task that has a void return type and does not return anything. And we'll see this uses internal start new. It eventually goes through a couple different methods, passes in that action. Once again, we're passing that delegate just as some stuff that we work with, right? So if we look, we're going to now create a new task. First parameter is that action. So we're going to call a constructor, and here's that action. And again, as we talked about in terms of designing the contract, notice that the first thing it does is if the action is null, if I pass a null delegate, throw an argument null exception, right? We can't create a task that runs null. Do some other validation. We're going to call task constructor core, dive down into some more shared code. We now have this object. We're going to keep working through, et cetera, et cetera. And now we're going to add some things into the thread pool, and eventually, let's just figure out exactly where that gets used. We're going to set its action method to that particular action that comes in. We look at where that gets used. we've got some asserts working with it, but eventually we are going to assign it. Well, that's where we're running it, or where we're just looking to display the method description. Elsewhere, when we go into looking at our action, we are going to dive in. We will call that method, and we may get the result. Notice that we're casting it to see if it has a result. If it doesn't have a result, that's one of the invoke methods. There's going to be a number of different places where, depending on the signature, it's going to eventually invoke the method once it's crossed over to another thread.
Yeah.
So we're passing this delegate around and eventually running it in a particular context.
And I think in that particular method there, you can actually see the way that you would call that delegate, whether it had parameters or whether it didn't have parameters.
Right.
So maybe you can show that again there.
So in the first method, we can see that if it does not take any, if it doesn't take any parameters, we call func with open parens, close parens. If it has some state, we're going to put in the state that we look at, and we're going to call that with some other object, which would be the state to initialize the delegate to run this particular task. So there we're, once again, what we're doing from the outside is we're going to start a task on another thread. That task on another thread, we're going to give it a delegate to say, go run this task on some other thread. If we go back into our playground, the way I would do that is, let's say this had to do just a whole lot of work. I may do something here where I'm going to introduce some interesting syntax. Is if I say this is private static async, and I'm going to make this particular delegate async, and I'm going to await this calculation, which should be able to do. And now this signature is now going to return a task of double because it's doing some asynchronous work. And what I actually want to do now, we should be able to do that. Yeah, that should, and that's now going to be a lazy of task of double, because now we're introducing this asynchronous work on some other thread.
And you can see right here the generics giving us some benefit. That's giving us some compile time checking that.
Make sure I'm doing this correctly. Right. Yeah. So now, in this part, what we do, and now down here, what I need to do is this dot value dot result, because we're going to wait until it actually happens. And then again, this one will block, but then that may be the semantics I want. And if I were to do something here, I would do task dot run. I'm going to say that my result equals await task dot run. And we'll say, we'll just make that return. We'll do two different statements in here. This is not the kind of code I would want to write, but we'll just say, let's delay 1 second, and then let's return math.py.
And so we're just simulating maybe a network call.
Maybe some kind of a network call there, and then we can return the result. And result here should be declared as a variable, and there we go. So now task.run is going to execute that delegate, which is going to do this spin wait for a second, or at least wait for a second. Again, don't do this in production code. This is not meant to be production code. It's meant to show what the contracts look like. And then it's going to, at the end of just chilling for a second, it'll return math.py. And then once we've completed that, by awaiting that task, we wait for it to finish its work. Then we've got the result, and we pass that up through to our lazy of double. So now we've started this, and we've introduced some idea of running this in the background and seeing what kind of things we can do off in another zone.
Yep.
Okay.
Okay, so next we took a couple different looks at how we're going to use delegates, but this next one we're going to take a look at is system.progress of type T. And we're going to be, this is more of an event scenario where we're going to be raising the events of the progress for whatever task we're working on. We're going to be raising that up so that we can report it to maybe potentially a UI.
Right. So the two that we used before have been both delegates, right? You had to supply something. Task.run was going to fault if I gave it null, or if I didn't supply a task. Lazy of T is going to fault if I didn't give it a factory method. Progress of T, which implements this interface called iProgress of T, which now says I've got this thing where I can report, here's where I'm at, okay? So this is an interface that says I can report, I've got some updated progress, okay? And if we look at the way progress of T implements that, we've got some handler in here, and eventually I'm going to have this event handler of T for progress changed, okay? And if we look at that event handler of T definition, once again, we've got obj event for sender, T event args, and notice that in the latest version of the .NET framework, where I was saying that previously event args had to return something that was based on system.event args. It doesn't anymore. After .NET 4, they've made this change, expanded the contract a little bit. Events may not always have event args that are derived from system.event args. So now we've got that particular event handler is in place. And now if we look at what progress does, one of the things that it adds for us is a method called onReport, which is a virtual method. And now it's going to implement the code to say, if I want to report progress, if something has subscribed to this, then we're going to do the work to say, let's post it onto that event and let's let subscribers know about it. So it's going to look at this event handler of T. That's that event handler we just looked at for progress changed. If it's non-null, well, then what we're going to do is we're going to post onto the synchronization context, which is a way of dealing with threading in your, primarily in Windows is where that may show up, which says if we're going to go do that, post it and post it onto the UI thread if it's a windowing application. Here are all our handlers, and here's the value that has to get passed on. Okay, so we're making sure we hit the right synchronization context, which just in terms of how that gets constructed, we just get the current, if we're not supposed to flow the context, or we get the default context depending on where it's running in. Okay, so basically that's just going to get the proper context in a windowing system or a default context if we're not running as a Windows windowed program with an event loop. So if we're running an ASP.NET app or something and reporting progress differently, we end up with something like that.
Okay.
So let's look at how we might use that one. So if I were to use progress of T, let's just dive down and I'll make another small class here. And let's just say I had some, we'll make a public class, and we're just going to say it's my event source. And it's going to derive from, not predicate, but progress of int. And one thing I may do here is I'm just going to have an async method, because usually if we're reporting progress, it's going to be something that's running on another thread or in another context, whether it's a network request. Probably can't report progress on that effectively, but probably in this case doing some work on another thread. So that's going to introduce some asynchronous work, and I'm just going to make it a task of int. And this is going to be where we're performing some expensive calculation. And the way we're going to do that, what I'm going to do is I'm just going to say I've got a sum that's equal to 0, and we're just going to run a loop here. We'll just go, say, 1,000 times, and we'll just increment I, and I'm going to say I want to await that task.delay. We won't wait quite as long. We'll just give it 100 milliseconds here. And sum plus equals I, otherwise spelled with a 1 occasionally. And then I'm just going to say this dot on report. So I'm going to report progress, and we'll just report where we are in our summation at this point. And then when I'm all done doing all that work, we'll return a sum. Okay? So now if I wanted to use this, what I can do to attach an event handler is I'm just going to say, in this, we'll just say var my source is a new event source. And we're just going to say source, which I spelt wrong. Let's go fix that so it's a little bit easier for folks watching at home. And we'll just say source. And you see I have this event handler, progress changed. So I'm going to hook that up to a bit of code, and I'm going to say for progress changed, we're going to make that equal to an event handler. We're going to take, I don't really care what the sender is because I kind of know. So I just use an underscore to indicate I don't really care about that. And we'll just say current progress. And I'm going to use a Lambda here, and we'll just say console.writeLine. And I'm going to use a new C# feature to write a formatted string. I'm going to put a tab, and we'll say current progress. And that's going to be my progress. So I'm using an interpolated string there. It's going to be with a lowercase p to get my progress.
Which means that you get to be able to write and use the C# syntax right inside your string there.
Yes, and I think I need 2 there. There we go. So with the 2 curly braces, yes, I get to use the C# syntax. So this is the value of that variable progress. And I am clearly doing something incorrect because it should be a single bracket. And you're telling me what? Yes, it does. Context absolutely exists right there. It's right there. Spelled right, because I spelled it wrong, that's why. There we go. Typos, the bane of every live demo. All right, so let's just move this on another line so we can avoid a little bit more scrolling. So now that I've attached a progress changed event handler, and now we're just going to call that and say, eventually we'll just console.writeLine my source.perform expensive calculation. And there we go. And since that's a task of int, I'm going to want to wait here. So I'm going to just wait for the result to come back. So I don't want this to be async per se. And now we can run it, and I can see it should fire up, and we're going to start seeing that progress pop by every 100 milliseconds, right? And once it starts adding, there's our progress coming back with that event handler. Okay, feels reasonable, getting some answers. And then as that finishes, we'll find the final sum coming out when I print just the integer on the line that hits the bottom. So I probably may have gone just a few too many. Let's shorten this because I want to, yeah, we'll just make this, let's just do 10. That won't take so long. There we go. So I do 10 sums. You can see the sum is 45. I'm going to make it up to 50 just so we get a little bit of a delay. So this is coming through that event handler. And now if I don't attach the event handler in our main program here, just comment out that line, do the same run. It's working. We might feel uneasy because we're not getting any feedback, but it is working, right? It doesn't crash. It's not like one of our previous ones where we were talking about lazy of t, where if I pass null, it was just going to crash. Here, what we see from progress of t, because it's raising an event, if there are no listeners, it's not going to do anything in particular. Okay, so that's basically how those work. So we have that event handler, that's implementing that optional contract. We have those delegates that introduce some of the required implementation that may be needed for a particular algorithm, showing the distinction between those. And notice that they do leverage generics in a lot of ways. These outbound interfaces, they don't necessarily have to, but they will often leverage generic arguments or generic return values for the work that they're doing.
Great. Well, thanks for showing us all that code. And I think up next we're going to be talking about the lab exercise that we're going to be working on. So we'll move right into that. We're going to be discussing how we're going to add outbound updates to the various things that are happening inside our classes there. So first up, all the students should be able to be notified when there's a teacher that offers this new class. And so we want to figure out how do we notify the students when the new class is added. And so we're going to take a look at whether or not we use delegates or events in that situation. And finally, we want to notify the teacher when the student finishes a particular assignment for the point grade and can assign the point grade to that assignment that they're working on.
And so with that, this one may take a little bit more time. There's a little bit more code to write in addition to a little bit more design decisions to make. And after you come back, we'll discuss the solution that we came up with. See you soon.